Today's episode was recorded on the UCLA campus in Los Angeles, California on February 18th, 2025. Please be sure to check out our other episodes, including one with Questlove on the topic of nurturing ideas in children. Don't forget to click subscribe and please rate the show on your favorite podcast platform.
So here's the just so story. You're a prey and you're being chased by a predator and you hide. Now, if you're hiding from a predator, you're obviously very nervous, your heart's fluttering, you're breathing fast. If you can calm down, that's going to improve the likelihood you survive. One way of calming down is to breathe deep. And so we think that the survival of early mammals was improved by their ability to breathe slowly.
Welcome to Sing for Science, the show where musicians and scientists talk about music and science. I'm your host, Matt White. Each week we'll talk about a song by our guest artist and how it connects with our guest scientist's area of expertise. Today we'll be speaking with Tyrone Lindqvist from the hugely successful electronic music group RÜFÜS DU SOL. What sets RÜFÜS DU SOL's live show apart from many other groups in the genre is their capacity to expand songs into extended meditative and improvisational performances. Their latest album is entitled Inhale, Exhale and was inspired by a communal breathwork exercise conducted here in Los Angeles. Breathwork refers to a set of techniques that involves intentional breathing patterns designed to improve physical, mental, and emotional well-being. Also joining us is UCLA Distinguished Professor of Neurobiology, Dr. Jack Feldman. Dr. Feldman is perhaps the most well-known expert on human breathing, having discovered the region in the brain that controls our breathing patterns. Jack is himself a breathwork practitioner and can speak in great detail to why controlled breathing can influence the body's physiology so dramatically. The title of this week's episode on the podcast is Inhale, Exhale, the science behind conscious breathwork. Hello, Tyrone and Jack. Thanks for coming on Sing for Science.
Thanks for having us.
Thanks for having us, yeah.
So I think you may be the first artist that has a breathwork-inspired album title, yes?
I don't know. I couldn't tell you. I'm sure there has to be others.
Yeah.
Can't be the first.
Well, it's part enough of the general zeitgeist right now, breathwork.
Yeah, true.
So what happened? What's the story?
Well, my relationship with breathwork probably started with my wife's dad, actually. He said, did you want to do this Wim Hoff breathing? It was like a one-day course. And we went and did that, and it ended with like a cold plunge. And that was a one-off experience, and I didn't do it again for like probably 6 months. And it was an overwhelming experience because we'd go through and essentially, inhale, saturate our brain with so much oxygen that we would, start having these very psychedelic experiences while lying down. And it was really, really incredible and unique. And I'd never had any experience like that just from, using breath. And anyway, and then fast forward, we as a band had, made some shifts. We'd been touring for like maybe the better part of 7 years. And we're from Australia. We came over here and, tasted a little bit of success. And it was an exciting time to be on the road. We're in tour buses. And so I wouldn't say it was the healthiest lifestyle in the big picture, and it wasn't sustainable. So there was a point there where we were all like, let's work out how to make this sustainable and enjoyable for ourselves. And so we pivoted on a lot of the just small things within our day-to-day on tour. Like whiskey shots went to ginger shots. And I don't know, we trialed breath work. We'd done something when we were making a record. On the previous record, it was like I think it was during COVID, so it was like an online guided session over maybe 45 minutes. And we again had that really overwhelming experience where you're in your body, but you're also, having the closest way I can explain is like a psychedelic experience, really.
Is it like panic inducing?
I guess, yeah, when you're doing so much so when I say like hyperventilating, it's essentially you're inhaling so much and exhaling so rapidly over the course of maybe 2 minutes, 3 minutes, and then you'll do a breath hold. So you'll inhale and then you'll hold, and maybe you'll squeeze your whole body really tight, and then you'll let loose and exhale, and then you'll hold there. And you'll experience tingling, or some people will get twitching hands, and everyone has their own sort of experience. But over the course of doing it for like 20 minutes, 30 minutes, the experiences get kind of incrementally more intense. And after it has to be so close to meditating. I don't know the science behind anything, but my personal experience after it is just extremely present, out of my brain, like out of my thought processing. Like I'm very just present to my body, to the room, to the sounds, and it lasts for a few hours, I would say. Like you just feel amazing. So after having that experience, we're like, we should definitely be doing that on tour. And so we do it before we go out on shows. We just do sort of a 10-minute session before we go out. And it's really, really, it's a great way to just center ourselves and bring us into our bodies. And, you know, because you never know what you're going to do walking out on a show. Like, I mean, you don't know whether you're going to be present for the show. Yeah. There's so many factors and a good show at this point in our career isn't, you know, someone saying you did a great show. It really is our own experience. Like, were we there? Did we enjoy it? Right. Like, did we give everything that we could give? And were we just, you know, there to enjoy it? That's a good show in my books. Sure. And so that, like a cold plunge, we do that after. Do you bring the chillers on your tour buses? What, the chillers? Yeah, to keep, or do you just use ice? We use ice. Okay, yeah. Yeah, it's, we love it. Yeah. But yeah, everything, you know, that we've built in terms of our touring lifestyle is, you know, trying to optimize our body's ability to just be. To center. Yeah, to center. You get off a show and you're buzzing, you know, however many people you're playing in front of, singing songs that you've written. It's a really overwhelming experience that it's so cool. And you walk off stage, and there was definitely a few years there where it was hard to have a conversation with someone that didn't have that experience, because you're like, I don't even really want to talk. And it's not like, I don't know how to explain. It's just you're energetically in a different spot to the person you're speaking to. And so you almost just want silence. Yeah. So a really nice way to down-regulate for us when we get off a show, and whatever's happening for you, you get in the ice bath, and it's like forces you straight back into your body. Yeah. You're like, you know, have to really hone in on your breath for say 3 minutes. Yeah. And that's such a key part of us. Yeah, I imagine, you know, one part is you having to deal with the extreme cold. Right. But while that's happening, to get through it, you're taking deep breaths for 3 minutes. So when you get out, you feel amazing. Yeah, sure. But I'm sure that part of that is just the fact that you've been doing deep breaths, centering yourself. So breath work has been a big part for us. And I guess, you know, in terms of the album that we just did, Inhale, Exhale, we had written, I think, maybe 10 songs, and we were going to show a group of people in Breathwork. I guess it's a yoga studio, Breathwork studio. They do sound healings. It's in Venice. It's called Open. And they do really cool things there. And our manager was like, maybe we do, you know, a listening party there for some of these songs to get a feel and a read. so we'll do a 20-minute breathwork session and then play 20 minutes, 30 minutes of music. And that was really exciting to us because often when you're playing music to, you know, anyone that's corporate or just anyone for the first time, there's definitely nerves. It's a bit stiff and stale in the room. You're sitting down and, you know, whether someone likes it or not, you know, you're kind of staring at the floor like, ugh. You know, I don't mind whether you like it or don't like it, but I just don't want you to feel uncomfortable. And I don't, it's just funny experience. But
breathwork kind of just dials that all down, right?
It did, yeah. Yeah, well, you know, before we go into interviews or anything, we do, you know, whether it's 1 minute of just breaths, it just really centers us. I know the guys do it too. But that experience was so cool because we were lying down, we did 20 minutes of breath work, we played the songs, and it was like we got to hear the songs for the first time, you know, and before they were finished, they were just kind of rough demos. And after that, we were like, I think this is a real, you know, staple piece of whatever this body of work is that we're creating. Like breathwork has felt like a big part of our last 3 years. Maybe that's a fitting title. And then we kind of, you know, flesh out songs and hone in lyrics to lean into inhale, exhale, breath. It's not, we don't consciously go into making a record and go, let's do an album about, you know, breath. We're just not that band. The kind of concept or something will kind of emerge and we'll be like, oh, that's what it is. All right, let's turn up the volume on those things a little bit and then we'll have an album.
Yeah. Okay.
Yeah.
What I like about it too, and this may be a stretch, but because I've heard a lot in Jack's work, he's talking about oscillators. And since you guys use a lot of synthesizers, oscillators are the primary component that, you know, emits the sound. And there's something in the title, just in the appearance of, in all caps, inhale/exhale. It looks like a computer programming command, you know? And I think, and I also, in hearing Jack talk about the mechanics of breathing and the on-offness of it, and what's passive and kind of what's more deliberate, there's a lot of resonance. So Jack, I'd love to hear you talk a little bit in response to what Tyrone was just describing.
It's a great story, Tyrone. I'm kind of late to the game of breathwork. My academic career started looking at breathing because I thought it was a way of trying to understand how the brain worked. And my PhD advisor refused to allow me to work on what I thought were the most interesting problems, like cognition and speech and vision. He said, those are too difficult. You need a simple problem you can solve. And so I looked around and I said, oh, breathing got to be pretty simple, right? It's just how the brain generates a sine wave. And that should be pretty straightforward for a physicist to figure out. I was a PhD student in physics. And I did a lot of reading, did some modeling, and then started to do experiments. And it turned out to be a lot more complicated. And being pretty stubborn and persistent, I've been working ever since trying to figure out what the basic mechanisms of the brain to generate this thing that's reliable. You start in the 3rd trimester to practice because you have to be doing it as soon as you're born. And you do it basically continuously for your whole life, for maybe up to 1 billion times. So how does this nervous system do it? And it has to not only be reliable, it has to be very labile. You know, you get up and walk out of the room and your ventilation, the amount of air you're moving, has to triple. And you have to do it quickly because if you go 50 meters without doing that, you're going to pass out. And it is all done without thinking about it. So it's an incredible problem to try and figure out. And breathing has evolved in so many things besides just the movement of air. Speech, I have to control my expiratory airflow, or singing. You have to control your expiratory airflow, but then you can't do it for minutes at a time. You have to intersperse inhales to get the oxygen into your lung while you're singing or speaking or whatnot. And the question is, how does all gets orchestrated in ways that we don't really have to think about? And about 10, 15 years ago, I got curious about breathing and emotion. I was reading about meditation and whatnot and wanted to try and figure out what was going on. And at the same time, we had done a study about sighing. So I think everyone knows that when you're nervous, you take a deep breath and that relaxes you. You don't have to do even 5 minutes of meditation, but you're going to perform, I'm going to speak to colleagues, you're playing a sport. One deep breath does it. Why does that work? And then there's the aspect that if you do breath work over a period of time, you get long-lasting effects. It does calm you down. It was a recent study which looked at thousands of papers having to do with breath work, and they came to the conclusion that 5 minutes a day for a month produces long-lasting positive changes in emotional state and physiology. So this is all great. And what I want to understand is why. What's going on inside the brain that's happening? And so the study on size really started out just trying to understand the phenomena. We sigh every 5 minutes because we need to do that to keep the lung healthy. The lung is a pretty amazing organ. The way oxygen gets into the bloodstream and the way carbon dioxide leaves the bloodstream is by passive movement across the membrane. So you need a large membrane. It's all passive. The membrane inside your lung is about 70 square meters. So you have, that's about a third the size of a tennis court. So to fit all that into your lung, which is about maybe 2-3 liters, you have to have all this branching. And at the end of the branching, there's these small spheres called alveoli, each about maybe 1/100 of an inch in diameter. And they're marvelous. And by each one is a little capillary that goes by, so you have the gas exchange. But the alveoli are fluid-lined, and they have a small tendency to collapse. And if they collapse, they don't just open up. You got to take a deep breath to open up. So we evolved to take that deep breath about every 5 minutes. We don't notice it. We just do it. And when you ask people,
I just had to do it. Just said.
I asked Tyrone, and he said maybe 10 times a day. And I said, well, if you did it 10 times a day, you'd be dead.
Yeah.
So it needs that force because it gets stuck together. And are those the actual air sacs that you're describing?
Yeah, the alveoli, right. Okay. So you can do the experiment yourself. Take a balloon, put some water inside, squeeze all the water out, but make sure the sides are stuck to each other, and then try and blow it up. And you realize you have to really blow very hard because the water has what's called surface tension. It sticks to itself. So you got to blow it up. And it's the same thing with our lungs. And it's true with all mammals. And we're special because we have this huge surface area in our chest, but that means we have to pop open these alveoli, which are collapsing. And so we did a study on sighing, and through that, we came to realize that sighs were not only important in the physiology, but were important emotionally. One of the fellows in the lab was reading that when we're anxious, we increase the sigh rate. And that seems to act in a way to relax us. So just like taking a deep breath relaxes you, if your brain induces you to sigh, it's going to relax you a bit. So if you're anxious, it actually is working in a direction to make you calmer. So when he looked at this, when you're anxious, a region of your brain called the hypothalamus, which is involved in emotional control, releases these molecules called peptides, and a particular kind of peptide called a bombesin-related peptide. And so these two things, you sigh more and these peptides are released. So we said, maybe they're related. So we went out and got the peptide, and when we injected into this region in the medulla of rats called the Prebutzinger complex.
Which you discovered.
Which we discovered and named, and we could talk about how we named it. But which we discovered we injected in the rats, which sigh about 40 times per hour. The sigh rate went to 500 per hour. So it just, the sighing exploded. So it looked like these peptides were critical in the way that emotion was going to change sigh rate, because if your hypothalamus releases it when you're stressed, it's going to cause you to sigh more, and causing you to sigh more will have the feedback of relaxing you, so to reduce the effect of the anxiety. And while we were doing this, we had colleagues up at Stanford who happened to localize where these peptides were in the medulla, in the region involved in generating and controlling breathing pattern. Not in the hypothalamus, they were in another region nearby. And so we put together a story. It got a major publication and it went viral. And that was fun because not only was it published in a leading academic journal, but it was in every newspaper. The Onion wrote about it, and that got a lot of cred with my kids because they don't read the scientific journal, but the Onion, and even Cosmo wrote about it, Cosmopolitan. So, which is an unusual trifecta for an academic scientist to be in those places. And so that began to catch the attention of individuals who were in the breathwork community. And then we published another paper, which was originated by observations by our colleagues at Stanford, who showed that there was a projection from the pre-Butzinger complex to not to regions involved in controlling breathing, but to a region called the locus coeruleus. And the locus coeruleus is a way station that projects, goes to the entire brain. And it's important in involving our alertness, our state dependence with sleep-wake. And so a breathing rhythm goes in there, it's going to go everywhere throughout the brain. And we showed that when we were able to remove the neurons going from the pre-Butzinger complex up to locus coeruleus, but not the ones going to regions controlling breathing, the animals still continued to breathe, but they were much calmer. So we put together a just so story that the signals related to breathing are going throughout the entire brain, and they're playing some role in determining our status with respect. Sorry about that.
Please.
We're going to affect our emotional state. So that also went viral. And when it went viral, I had a colleague in the Department of Psychiatry who I had never met, even though she's just across the way there. Didn't read the journal in which we published this paper about the projections to locus coeruleus, but read the New York Times article about it. And she then called me up, and we've been working together ever since. She works with human patients who are very stressed and uses yoga and breath work to help them manage their stress level. And she does things like brain imaging in humans, and we do the work in rodents, and we've been trying to pull this together. And
can you give an analysis of what Tyrone was describing with the Wim Hoff method? You know, like what is actually happening, both on a mechanical and the phenomenon in the brain? What's happening?
All right. I won't start with Wim Hof. Let's just start with why breathing should have any effect at all. The brain, you have a signal coming in when I'm speaking to you. You hear me and you see me, but it's all coherent. It's all, you see it as one thing. You sense it as one thing. But the signal coming in your ear and coming in your eye, two different pathways. How does your brain know to tie it together? Like, we all have had the experience when you're watching a movie or a TV and the soundtrack gets a little bit displaced. Your brain has a hard time figuring out. It's very annoying. So how does the brain figure that out? Well, one of the ways the brain figures it out is that there's like clocks in the brain. Just like there are computers. In computers, there's a clock. Well, there's these oscillations. And so when a signal comes in here and a signal comes in through your eye and they converge, depending on where they are in that oscillation, the brain can figure out whether they're related to each other or they're unrelated. So the signal coming in from my voice to your ear and the visual signal are coming in at pretty much the same time. Actually, there's a slight delay because the sound is slower than the light, but that's in the microseconds. The brain is sensitive to small changes in the millisecond, thousandth of second range. And so it pulls it together. So there are all these oscillations at various different frequencies. The fastest probably being 100 times per second, down to now breathing frequency, which is probably every 5 seconds.
When you're talking about oscillations in terms of sound and vision, are we talking about waves?
No, I'm not talking about the oscillations related to my auditory signal in the ear causing the membrane to oscillate. I'm talking about the brain itself is generating these rhythms that get dispersed throughout the entire brain and act as a way for the brain to coordinate or to cohere the signal. It's called binding. In other words, it binds the signal coming in from different places, so the brain understands that it's related, it's tied together.
This is news to me. Did you know about this? About the brain producing these oscillations?
No, I didn't. I mean, my wife did a sound healing course, and she, this is sound related, but I wonder if it's somewhat, but she spoke about entrainment. So if there's, a bowl that is a C, a middle C, whatever, and there's something else that's close by in pitch in the room, and you start, dialing up the volume on that particular tone, the other, close by pitch will start vibrating. And so they start, oscillating at the same rate.
There's a lot of data that external oscillations, if they're tuned to a particular frequency, can affect brain function, nervous system function. So coming in through your ears or visually, then if there are oscillations in the brain which are close by, then they can begin to resonate with each other.
And the oscillations in the brain that you're talking about, so are these electrical signals?
Correct.
Okay.
Yes,
that's just always happening, and that's how the brain does its thing.
Well, it's a way that the brain is able to function coherently. Because the brain has lots of parts, and the question is, how does one part know what's going on in the other part in ways where we need to pull them together? And so with my analogy about sound and vision, it's pretty straightforward that we have to make sure that it's coming from the same place, and it's natural now. I mean, hopefully I'm just my voice is not incoherent here. So these oscillations are present, and up until about 10, 15 years ago, most of the oscillations, or all the oscillations, were much faster than breathing. And then people were, in measuring brain oscillations, electrical activity, realized that there were oscillations related to breathing throughout the entire brain. And then there was data that if you begin to interfere with the breathing oscillations, you get changes in the functionality of the brain. Now, these signals are coming in with respect to breathing from a central origin, that is from the pre-Butzinger complex going into all parts of the brain, like through the locus coeruleus, but they're also coming in through your nose, because your breathing pattern is air in, air out, and you're stimulating the olfactory receptors, and those go into your brain, and they have a respiratory modulation. Your lungs are expanding and contracting with the breathing cycle. There's a very powerful signal coming from the lungs into the brain via the vagus nerve, which is a very important nerve for signals going from the brain to the viscera and from the viscera back into the brain.
And viscera is guts, that's all organs.
Lung, guts, all of that. So the brain is able to send signals out, but it also gets signals back. And the signals coming from the lung itself are respiratory modulated, because the lung is expanding and contracting, and we have special receptors in the lung that respond to that stretching contraction of the lung.
And that's that movement that sends the signal to the brain?
Well, it's the movement which triggers the sensors. These are specialized nerves that when they're stretched, they produce a varying signal which gets electrically transmitted into the brain.
Okay.
Okay. So there are all these places where signals related to breathing could be coming in. Now, if they're involved in normal signal processing, now suppose they're involved in normal signal processing, and now I disrupt it. I slow it down. You go from breathing 15 times per minute to 6 times per minute. To the degree that they're involved, it's going to change the way the signals are processed. So in the short term, a deep breath throws those circuits off, and the response is, for reasons that we don't know yet, it's calming because it throws that signal off. One analogy I'd like to use about the long-term effect of breath work is, imagine you're walking around on soft ground, you're walking around in a loop. Gradually, you're going to wear away at the turf, and you're going to start making a rut, and the rut's going to get deeper and deeper and deeper. Well, if you can imagine, by analogy, something like depression being activity going around in a loop of neurons, and in the nervous system, if things repeat, the connections get stronger. So you can imagine if that's happening and it gets stronger and stronger and it produces a sense of depression, the connections can get so strong that it's hard to break out. And we know that depression can be very difficult to crack open. One of the ways we can crack open depression is by what's called electroconvulsive shock. We put electrodes on the skull and we send a powerful electrical signal. What that does, it disrupts that circuit. And when the circuit gets disrupted, signals now the connections between neurons can begin to get weaker. And as they get weaker, you get some relief from depression. So electroconvulsive shock, you give it to people who have depression, severe depression, they'll get temporary relief. But it's not permanent. But if you do it again, they get more relief. And if you repeat it again, they get more relief. Now, electroconvulsive shock is pretty heroic. But now with deep brain stimulation, where they stick electrodes into particular parts of the brain and produce local disruptions of the signal, you can also get benefits with weakening the circuits for depression, and therefore you get relief. Now, we think that you get the same effect with breath work. That is, the degree that breath work is involved in the signaling pathway for depression, that's that oscillatory signal is there. If I disrupt it, I begin to weaken those connections. Now, I may not see an effect for doing breath work for 5 minutes, but if I do it 30 minutes a day for an extended period of time, I may wind up breaking down the circuit. And so there's, I think, pretty good data that breath work can be effective in treating clinically diagnosed conditions like anxiety, depression, and whatnot. It may not work for everyone. And it's sort of like you have this rut, and what the changing your breathing signal is like filling in the rut. When you gradually fill it in, that somehow the rut becomes small enough that you can actually climb out of it. Now, that's a pretty simple-minded analogy, but that deep down, I think that's what's happening. And that's how breath work is having such a powerful influence on the brain, because breathing signals are involved in everything. Now, if we go to simple forms of breath work like box breathing or 4-7-8, where you inhale for 4 seconds, hold your breath for 7 seconds, exhale for 8 seconds. Or you do box breathing, you go 4-4-4-4, inhale, hold, exhale, hold. My understanding is Navy SEALs, when they're in the conditions where they're subject to stress, and I would suspect they're under more stress than you and I are under certain conditions, that they use to calm down. So it can have a powerful
the box breath.
Box breath.
Yeah.
Now, Wim Hoff has and there are many different kinds of breath work, and I analogize it to exercise. If you're a couch potato, I don't say jump into Wim Hoff. I say walk around the block. Just don't strain you, walk around the block. Then walk around the block 2 times, then 3 times. Once you start doing that, maybe you can begin to jog. And then as you become more fitter, you could say, okay, I want to train to improve my endurance or my power or my strength. And that would determine which kind of exercise regimen you would use. And there are different ones, depending on whether you're a sprinter, long-distance runner, power lifter. I think it's the same thing with breath work. That is, depending on you as an individual and what your goal is, different kinds of breath work may be optimal for you.
It's funny, though, that your father-in-law just fast-tracked you to it's your father-in-law, right?
Yeah, he's tapped into the newest and greatest things. He's a doctor himself.
But that he brought you right to the most extreme one.
I think he was curious, and I love that about him. And it was an extreme experience, and it was eye-opening. And yeah, since then it has been more of a gradual step in and more trial of the different types of, like, box breathing. Yeah. They do have different effects, and I do think it is really dependent on what you're after. So before a show, like, do we want to be amped? So we're kind of checking in with that. Are we a little bit dazed and confused and not present? We need something that's gonna, like, upregulate, like, basically get our systems running. And so we would do something more like a Wim Hoff esque breathwork thing that's short, fast, and oversaturating our brains with oxygen, and then, you know, getting a buzz. And then just before we finish, we kind of calm down, so we're ready to do the show. And sometimes if we're, like, more anxious, or, you know, there's a lot going on, it's a lot of stresses, sometimes box breathing is the thing that we'll do, and we'll just stay in the box breath for, you know, most of that 10 minutes. And we'll do a small portion of something more intense. I don't know. I do think that they're more like tools, and the more you try them, the more you learn how your body reacts to it and how you respond with it. But I don't do it every day, and I would love to do it every day. We've been really good at implementing it into our touring cycles, so it's been really good in terms of our touring. Before interviews as well, I would maybe get more nervous initially, and just doing, say, less than a minute of deep breaths, like rapid breaths, would put me in a place where I'm less in my head, more in the room, and I'm good to go.
You do it through a show?
No, well, because I'm singing, I have to take a lot of breaths. So it's happening. It's happening during a show. So that is actually really nice. When I think about the other guys, I mean, yeah, I don't know if they have to do it more consciously because they're not singing. Yeah. But I know that it has been a tool for all of us. If we're having a tough time in a show, for whatever reason, we're not there, we're thinking about whether we put the laundry on, or whether, you know, did we pay that bill, everything except for being on the stage in front of these people. Or say there's someone in the audience that just looks like they're having a bad time, and you can't
not look at them.
Thousands of other people to look at, but that person is the thing that's standing out. Those are moments when you would use a tool like breath. Or I think there was one time, there was a period there where I had like some ice cubes, just like something to get out of my head.
Oh, wow.
But breath is the easiest, most accessible thing in that visually I don't have to do anything other than take a deep breath on the stage. And it really helps. It really, really, really helps.
A lot of people find Wim Hof to be very effective, but I think to start with that would be a bit extreme for most people. There's types of breathing like Wim Hof or holotropic breathing, which are very intense and very exhilarating, but you have to be committed for it. You have to be a little bit aware to take full advantage of it. But if you go in as a newbie and you start doing it, I think for the general public, it would be a real challenge. For someone who's young and fit and sort of adventuresome, they could jump right in. But I think for most people, a sort of a gradual approach is probably the one likely to introduce them to something that's effective. You know, if they start out with something that's extreme and it's not comfortable, they won't do it. And so here again, the analogy to exercise. Don't go out and run a marathon when you've been sitting on the couch.
Have you had this experience of almost it being psychedelic?
Yes.
What's that like? Are you getting visuals or?
Well, let me make a couple of comments about that. There was a paper recently about holotropic breathing, which is a very intense breathing pattern. And they in that paper, they claimed that the mental state at the end of holotropic breathing was very much like psychedelic-induced drug experience. So that's been published. And my experience was exhilarating, but it was very intense. When I was doing it, it was pretty intense. It's like, I'm very compulsive. I'm going to stick this out. I'm going to do it. But it wasn't always comfortable. Yeah. Now, that's not saying that's Wim Hof. This was a different style, but it was very intense. And I liked it, but I'm not running back to do it again very often because it was very intense. Now, you made the comment, Tyrone, when you do Wim Hof, you do this high-frequency breathing, you get more oxygen to your brain. Probably that's not what's happening.
Okay.
The amount of oxygen in your bloodstream is about 98% of the maximum. So in other words, right now when you're sitting here breathing normally, your oxygen saturation is about 98%. So when you breathe more intensely, at rest, it's not going to change very much. Now, if you go and exercise and needing a lot more oxygen, then maybe supplemental oxygen would be useful, or increasing your ventilation would be useful. But normally when you're hyperventilating, what happens is not that your oxygen goes up, but your carbon dioxide levels go down. Now, your carbon dioxide levels determine the acid-base balance of your blood, the pH of your blood. And all cells in the body are sensitive to the pH level. So normally we have a pH around, the number's around 7.4. But if you shift it up or down, all sorts of cell metabolism is going to shift. So your CO2 level is about between 40 and 45 millimeters of mercury, whatever that number happens to be. If you shift that by 1 or 2 millimeters, just a few percent, your body will respond. So I would say that probably what's happening when you're doing the Wim Hof style breathing is you're changing, not only in addition to the mechanical aspects of it and changing the frequency of breathing, the breathing signals in your brain, you are shifting the carbon dioxide levels, and that will have a profound effect on your neurons in your brain, as well as the rest of your body. Whereas the oxygen change is going to be almost insignificant.
Yeah, okay. That's so interesting. It makes sense, though.
I don't know if I'm allowed to contradict the guest.
No, absolutely. I'm here to learn. Yeah. I didn't go to university, so this is my opportunity.
Well, you're very open-minded, so I appreciate that.
You know, because I'm also an ice bath adherent, and usually, and I kind of relate to what Jack was saying, just comparing the ice bath to the extreme breathing. It almost sounds like something to be endured to get a benefit on the other side of it. At least that's my experience. But when you were first describing your experience, it sounded like it was very pleasant during.
Well, I definitely am a person, and I think the guys I work with are people that we're adventurous guys. We gambled our life on making music, which, if you were to statistically look at pursuing something like that, you're probably not going to have much success. Yeah. But we threw ourselves into it. We invested everything that we made into it. We believed in ourselves and the music that we were making, and we had fun doing it. And I think a part of our personalities is definitely that we're very open to trying a lot of things. And extremes are interesting somewhat. They're like, there's a pull to want to know what something feels like or sounds like, or how does the body respond when it's with this thing. For me, I can say I definitely, did enough psychedelics for a period of time. I don't anymore. And those experiences were really enlightening, and they really formed a big part of my spiritual belief system or understanding of me and the universe or whatever, and so I loved those experiences, and those didn't come lightly either. They weren't like, oh, I'm going to sign up for that again because, there might be 8 hours or 12 hours, but those experiences away from time felt like a year. I was there for a year. And, but I learnt so much within those experiences, and I got so much from it that there is some part of me that is willing to do the thing that is uncomfortable to see what happens and to see how I respond. That said, I have so much room to improve in terms of implementing it to a day-to-day thing, because I don't sign up for, more so breathwork, in that's like healthy, accessible, it's good for me, I know that, it's not a substance. I'm able to achieve some version of whatever that enlightening experience was just through air, oxygen, carbon dioxide, and I don't know. I think me and the guys are innately drawn to
extreme experience.
Some extreme experiences. I think we've learnt and gotten better at the more mundane.
Sure.
Because that is healthy. Like the extremes, trying to pull them in a little bit.
But let me ask you a question, Tyrone, because in many ways we have sort of a similar attitude in the lab. That is, we have to, we're always trying to do something interesting. Mm-hmm. We're not interested in things that are incremental. We want to make major jumps. And so I would say we're fairly adventuresome. And one of the mantras in the lab, and I wonder if this is, you subscribe to this, is you can't do anything interesting if you're afraid of failing. And I see a lot of young scientists feel like they want to do something incremental, they know it'll work. And my feeling is you're not really going to advance knowledge by just incremental. Like, what can you do that's really going to change things? But if you have an idea like that, it may fail. And so we fail all the time in the lab. And I had a brilliant postdoc once who came into my office after a year and a half of experiments that weren't working and was practically in tears and said, but Jack, everything you do works. And I laughed and I said, I took her over to a file cabinet back in the days when we had real file cabinets. And he said, this is filled with failed experiments. I don't publish my failures. But if I didn't do the experiments that failed, I wouldn't have done the experiments that were successful. And that's very important. Two other comments. One, part of my transition from being a cosmologist, which is the reason I went to graduate school in physics, to a neurobiologist, was psychedelics. So I went to college in the late 60s, and there were lots of psychedelics around. And I began to realize that the physicist's conception of space and time was markedly altered when I was under the influence of psychedelics. That is, space and time now, as shifts. And so I got really fascinated in how the brain works, and that's led me on this path. One other comment. One of the things that concerned me when we started to work on what the mechanisms are underlying breath work, it could be a placebo effect. That is, if you think it's going to work it may be the only reason it works is because you think it's going to work. And the question is, how do you test for placebos in human subjects? Because you can't hide things from them. And so the experiment is basically impossible in humans. We were able to change breathing in mice for 30 minutes a day. We got them to slow breathe. These were awake mice. They were in their chamber, and we got them to breathe slow for 30 minutes a day for 4 weeks. Then we tested them, and obviously no placebo effect.
Yeah.
And then we tested them afterwards on a well-vetted metric of fear, and they were much less fearful. It was pretty amazing how much less fearful they were. So the fact that we can see the effect of breath work in mice really indicates that it's not, there could be a placebo component, but it's not all placebo component because you wouldn't see it in mice. And we now think that this whole thing of breath work is something that we as humans mobilize, but that it's something that all mammals do. And so here's the just so story. You're a prey and you're being chased by a predator and you hide. Now, if you're hiding from a predator, you're obviously very nervous, your heart's fluttering, you're breathing fast. If you can calm down, that's going to improve the likelihood you survive. One way of calming down is to breathe deep. And so we think that the survival of early mammals was improved by their ability to breathe slowly. Now, it wasn't something that they can do breath work, but when they're in the right condition, they naturally slowed down, they sighed, they took deep breaths. And so this is probably now something you see, all mammals sigh. And so it's something we think evolved early that we ultimately hijacked in terms of breath work. But it's all animals will sigh, and we think under the proper conditions, they use their own form of breath work in response to stressful situations.
I love that you've spent your career in honing in on breath and the brain, and when we were talking about like just how I got into breath work and the guys got into breath work, just the many facets of implementing slightly healthier alternatives to our lifestyle. Like there are so many cool tools that do what you're saying. Like we have a 1.5-year-old puppy. I don't know if she's a puppy anymore, whatever. She's a very cute dog and she gets anxious and stressed pretty often, but one of her big things is she'll shake when she's had a stressful experience, and then she moves on. And it's like, I'd heard that that's a really big thing in nature. It's like any animal that has a stressful, fight, flight, whatever moment encounter, they shake or they go, or whatever it is, and then they move on and it's gone. It's like a physical response that you can do that must, I don't know the science, must have some chemical or brain, result to this physiological thing that you're doing. And I love that you've really honed in on the one specific part to understand. I don't
what's happening. Yeah. I mean, because it's fascinating. It is fascinating that, truly, you can, this may be a stretch, but you can breathe yourself out of any mood, right?
I don't know if I would be categorical in that, but I know you can breathe yourself out of certain kinds of moods.
Yeah.
Certainly stress, anxiety, whatnot. The breathing can be very helpful.
Yeah.
And as you point out, Tyrone, you can even use it to help exhilarate yourself. Sorry, I should shut her off. But you can do breath work without understanding how the brain works. Just much like you can drive a car without understanding how an engine works. So I have a lot of respect for people who are basically teaching people how to drive the car without really knowing what's going on inside, because in a sense, you don't really have to know.
Mm-hmm.
I have to know. That's my curse.
Mm-hmm.
But I think ultimately in knowing that, first of all, I think that our mouse study, when it ultimately gets published, hopefully will have a positive impact on individuals who think breathwork is sort of like one of these woo-woo things. You know, you have to believe in something in particular to make it work, that it actually may be beneficial for the normal life. You have a stressful situation, just sit down and take a few deep breaths, do 5 minutes, and people will discover it's restorative. Maybe not everyone, but a lot of people will find it to be beneficial. And to me, that's amazing, because I've been stuck in this place trying to figure out this relatively well-defined problem. That is, how is the brain generating this rhythm so reliably for a billion times throughout your whole life? And these, neurons are these squishy, unreliable biological things, and yet they're super, super reliable. And when you step back, you think, how the hell does this happen? Well, it doesn't just happen. And I ultimately think that when we understand how the brain is doing this, it'll actually help us understand some of the more complex things that the brain is doing. If you want to understand literature, do you start out by reading Shakespeare or Dr. Seuss? And so
Tyrone's father-in-law would take you to Shakespeare.
Yeah,
okay.
dive right in.
Yeah. Well,
Right.
Everyone has their own way of doing it. But to me, Dr. Seuss has nouns, verbs, sentences, and whatnot, and you get the basic structure, and then you can go up. Whereas if you jump right in and go into something like Shakespeare, I think is much more of a challenge. I'm not saying you shouldn't do that, but to me, that's the analogy that there are things we're discovering about how things going on in the brain that you cannot investigate for higher function. First of all, we're able to study this in rodents. There are a lot of functions which are considered to be very interesting you can only study in humans. And there are many things that simply you can't do the experiment in humans. But breathing you can study in rodents, and rodents breathe pretty much like humans do. Not exactly, but pretty much like humans do. And so there's lots of things we can learn. And then because that's a relatively in quotes, air quotes, simple, we can then begin to understand how other things are occurring. Like, how do you recognize your wife? Do you know how you recognize your wife? You recognize her.
Visual, how she looks.
But what's going on inside your head? I mean, we're beginning to crack those problems now about how you recognize something. I mean, it's pretty amazing. And I think from the ground up, we're going to be able to build these things. And so, yes, I'm terribly interested in breathwork, but I still have intense interest in trying to understand the nuts and bolts of how the engine is working.
Yeah, I really hear that with just how you got into it in terms of just understanding the brain is too big of a puzzle. Hone in on a specific thing, you hone in on a thing, and it kind of maybe will help enlighten, I don't know, something else about mystery of the brain. It's really cool.
Well, guys, I can't thank you both enough. This has been tremendous. So,
Well, thanks for inviting me, and it's a delight to talk here with Tyrone. I mean, I've learned a lot, and I see a much different perspective on breathwork and just how the brain works.
The feeling is mutual. I've learned a lot. I've probably learned a lot more than you've learned from me, but
I wouldn't know about
it's been great. It's been really awesome. Thank you. It's been lovely to meet you too.
Yeah.
Cool. Thanks.
You can catch RÜFÜS DU SOL live on their record-breaking stadium tour this spring and summer. For dates, please visit their website, rufusdusol.com. And you can keep up to date with Professor Feldman's work by following his Instagram page @JackLFeldman. Sing for Science is co-produced by Talkhouse and made possible in part by a grant from the Simons Foundation. Our music is by Panoram. Social media manager is Bailey Constas. Digital producer is Keenan Cush, and our location recording was provided by Alex Waxenbaum and Logan Regnier. Special thanks to the UCLA Neurobiology Department, Paul Misevich, Megan Dubkowski, and Irene Koo for making today's episode possible. If you like Sing for Science, the best way you can support us is to give us a review, tell a friend about the show, and subscribe on your podcast platform of choice. For more information, please visit singforscience.org and follow us on social media at Sing4Science. Thanks for listening.